Yeah, today we are doing Snark News Winter Series Round 3, which once again has a 10-day window, and this ends today, pretty soon. So, and once again we'll have 6 problems for 80 minutes, and I will translate the problems into English using an automatic translator, and we'll try to read them in English, even though sometimes it's a bit hard to understand them, but it's fine. So, I guess I will start in a couple of minutes, maybe at 40. Yeah, we can register. Yeah, I do handicap myself a little bit by translating, but it's okay. We haven't had Code Forces contests for a while, right? But today is Friday, and tomorrow will be Saturday. And we'll have Code Forces Division 1, right? 1 and 2. And also at Coder, I think. At Coder regular. Yeah, I probably will participate in Division 1, but we'll see. Resolution is only 1080. Yeah, I cannot do much about it, unfortunately. When I change it to 720, I think it's not optimal for most people. Yeah, the contest ID should be increased by 1. That's correct. 23,959. HTML and Notepad. Okay. Yeah, thank you. Yeah, so once again, I will not be reading chat while doing the contest. So feel free to discuss whatever you feel appropriate. And please be sensible anyway. And yeah, see you all in 80 minutes or sooner if I finish faster. Okay, starting in 8. Okay. Let's go. Okay, much faster in clicking the buttons now. what? Okay. Yeah, okay, I see what this problem is. It's probably not the easiest. Okay, what about A? Never was found in the image transmission algorithm. Okay, I guess no. Yeah. Yeah, I see. So yeah, I have some points on coordinate plane, and we need to count points. That lie on some yeah, maybe it's not the problem wait. Yeah, it's not the problem statement. Why? Pairs of stars, you know? Okay, just n stars, not pairs of stars. Pairwise different stars. Okay. In the same row with a star and in the same column with another star. Okay, I guess I see. Yeah. Not insert by, but I have to count. And now is that it? Okay, let's submit. Hopefully I got it correctly now. So yeah, everyone solved A as expected. Okay, B, some data structure problem, obviously. C. Okay, problem A accepted. Yeah, so we have two strings. Well, we have one string. We have to split it somewhere so that the sum has as many zeros at the end as possible. Yeah. Okay, I guess. We just want to do binary search. Well, at most n minus 1, I guess. And I want to figure out whether I can have this many zeros. It's still not easy. Okay, someone solved B. Let's read B actually. Okay. Min equal, max equal. Add on range and count values. Oh. Okay, I guess. Take a look later. Okay, what is F? Okay. Okay, what is D, I guess? Okay, this is some annoying geometry. Maybe not that annoying, actually. But like... Hmm. Okay, what's E? I have to split a graph into 2 clicks, kind of, right? Yeah, so it means that the... Yeah. One vertex can belong to more than 1 click, but like, yeah. It's still about 2 clicks. So the complementary graph should be bipartite, because I have 1 click and another click. Yeah, so I only don't have edges between them. So yeah, I actually have to... Yeah, in the complement graph, I have to take 2 independent sets. Yeah. Mm. Okay. Also, at least X, at least Y. Okay. So I need some knapsack in any case. Mm. I can only include a vertex in both if it has no incident edges. Okay. 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 Um, um, yeah. Well, otherwise... Um, Mm. Okay. Yeah, something like this. Yeah. Thank you. Okay, not equal to 0. Yeah, only put if vertex doesn't have a color yet. Submit. So, okay, nobody else. It's okay. Okay, accepted. Hmm. Yeah, okay, I think it should be not so hard. So we have some connected components. Mm, maximum these values. Okay, I think this is, yeah, probably D should be just of an intersection, like straightforward, right? Is it just it? I might be missing something, but like... Okay, let's see. If I actually copy this, will it work? It said I don't have my own implementation once again, but... what can you do? Yeah, like this. Phew. Okay. To the left of its line, okay. Okay, point and this, right? No direction. Yeah, I think like this. Does it even compile ever? Okay. So many warnings. to the left of this, to the left of this, to the left of this, and to the left of this, I think. Cross. Okay, let's see. Vector point. What's wrong? Okay. G here and here. Okay. How about no? Uh, Let's not compile. Okay. Oh, okay. Because, yeah, that's what I was actually doing. And submit. Okay. B, C, D. Nobody submitted F. Okay. Okay, G accepted. Yeah, C. Nice problem. So, yeah, in problem C, I can do binary search, but after that, it's still tricky, right? Like if I know the second number, I know what it ends with. Maybe just do F. Can you do F? I have some connected components, right? In each component, I can remove an edge if I need to, because I don't have enough connections. Or maybe I do need to do that because, yeah, yeah, like that. I think just yeah. So um, okay, so first of all, if I don't have enough connections, it's always no. Otherwise, it's always possible, but sometimes you need too many changes. So I want to find the smallest number of changes. And basically, I just need every connected component to have some free slots, right? Yeah. Yeah, if some component doesn't have slots, then I need to do something. I need 0. Okay. Components is 0. Yeah, if a component has some free slots, then it's just do nothing. Otherwise, I have to do something. Yeah, it could be a tree or not a tree. If it is a tree, then I have to remove some edge. I will have 2 more components and 1 operation. If it's not a tree, then I have 1 more component and 1 operation. I think that's it. Yeah. Okay, yeah. one thing doesn't work when I have just one component, right? Yes. If I already have one component, then it's always yes. But otherwise I have to do something, at least. Yeah, I think something like that might work. Okay, -1. 0 innocent. Okay. Yes, no. Well, it's a bit tricky. I'm not very confident. So for example, here, okay, let's print res. Yeah, I need one change here. And if it's something like this, then I need 3 changes. Yeah, I think it's correct. Yeah, and like this. Then still one change, yeah. And if I have, let's say, 4 vertices and 3 edges, and I know what k is, 2, 2, 2, 1, 1, 2, 1, 3, 2, 3. I need 2 changes. Yeah, that looks reasonable. And if, let's say, yeah, let's say I have 2 edges, then just 1 change. Yeah, I'll just submit. I don't know why I decided to test. I guess the problem just looks tricky. So yeah, for some reason I wanted to check some small cases. Yeah, it's still an answer in test 6. Mm-hmm. Yeah, I don't really understand what's wrong here. Oh, okay, I see. I see. Yeah, this check is not sufficient. Yeah, sometimes I have to do, yeah, sometimes I have to remove more edges than I want to. Yeah, okay. So yeah, I just need to count slots in my components. Why is it black, white? I don't know, but it's fine. So if I have positive, then just positive, yes. If I remove something, yeah, so it's always 2 slots after this, right? Because I have 0, so I remove 2 things, and I have plus 2 slots. Yeah, and in the end, what's the test case? So I have a triangle, 5, 3, I don't know how many, 2, 2, 2, 1, 1, for example. No, it's not a good test case. Okay. Okay, maybe like this. I say I need 5 steps. And this is correct. What's my problem? Okay, I see. My problem is that, let's say I have, yeah, like this, 3, 3, 3, 1, 1, 1, 1. Yeah, okay, let's see, 7 vertices. 3, 3, 3, 3, 1, 1, 1. Okay. Okay, whatever. Maybe just submit. I cannot make a test case. For some reason. Whatever. Yeah, it will not overflow. But like, 3, 3, 3, 3. So it's like 12. 15, 16, 17, 18. Okay, I have 10 vertices. I need 9 steps here, but without this, I would say I need 7. Yeah, I think this is okay. Maybe it's now correct. Let's try. Okay, everyone is solving C. Okay, F is running. That's good. Okay, accepted. That's good. Yeah, I should probably do C at this point. So yeah, I was thinking about binary search, but I'm not sure because, yeah, I don't have, like, the second length can be smaller. And the second number can be shorter than the actual number of zeros, which is tricky. So, yeah, I have a string. I take some suffix. So yeah, one thing is just maybe just fine to you could also end with zeros. Yeah, which is stupid, right? Well, not that stupid. It's okay. So once again, I have some suffix. I have substring. So yeah, for example, if I split here, I can probably just try every possible split and quickly count. I think that's easier, yeah. How do I quickly count? How do I quickly count? I can do binary search here, maybe with some hashes. Hmm. Mm. Yeah, I like the idea of checking every possible split. I'm not sure what to do next. Hmm. Interesting. Yeah, I can use some Z function. Like, yeah, at this point, I just go left. Okay, let's try. So, yeah. This. Okay, if not, none. Yeah, like this. Okay, I guess like this. Okay. Yeah, let's say I split here. Take z of 2 times n minus I. It's 1 minus I. Yeah, I think so. And now I take minimum of this n. And what? And how many characters I have in the first string, which is n minus 1 minus I think. This is not all. Let's see. Yeah. I might have more. Why? Yes, and also what else do I want to do? I want yes. And now if core is equal to n minus 1 minus I, if all zeros, then I want to have zeros, otherwise I want to have nines. Yeah, I think like this. Okay, so that's one case. Yes, and now the other case. Yeah, there I always have non-zeros. Yeah, I think something like this. Okay, not j minus k. Okay. Yeah, like this. And submit. 20 minutes. Okay, accepted. That's good. And we only have one problem. Yeah, hi Murat, thank you for the raid. But yeah, I'm not reading chat as of now. I have 20 minutes for one problem, which is problem B. What is problem B? Problem B is some data structure problem. What can we do? 7 seconds. Can we use some segment tree? I mean, you know which segment tree, but how to count nodes that have values in range? It's not easy. So yeah, I think it's probably hard to solve it in log time. What about square root? I can have just split into segments. And on each segment I have some, yeah, I think it's just kind of straightforward. I mean, not straightforward, but like something you have seen a number of times. In SNWS as well. Okay, I have some, I split my array into some buckets. In each bucket I have some numbers which are sorted. Like, yeah, does anyone know like how to maybe streamline such problems? Like, is it easy maybe to just type some library code that will solve all such problems? I don't really know. Hmm. Yeah, I don't know about this. Yeah, I think for each block I have some chopping segment and delta, right? So I have 3 values for each block. I mean, okay. Okay. Yeah, I'll call here as well. There. Mm, mm, I have 15 minutes. Yes. Okay, just do this. Like there. Okay, if I'm inside, then I have to apply this to every, like to the block, to the whole block. How do I do that? If yeah, I have some value as well. Okay, all values greater than x are replaced with x. Also, have delta and then think plus delta and then cut into the segment, right? Is it what I want? Really? Maybe. I think something like this. Okay, and then here. Okay. For third operation, yeah, I think like this. Okay, and now yes. AI equals what? AI equals AI plus delta ID, maximum of this and LID, and minimum of this and RID. I think. Yes. Eight minutes. Okay. Okay. Hmm. Hmm. Oh, but yeah, it's again this. Okay, let's just copy paste and then we'll figure it out. Yeah, for full blocks I have to do something. For for blocks like this I just have to do like this and like this. I don't like that I rebuilt them, but I guess I got time limit exceeded and then I figure it out. And finally here, yeah. It's just a binary search, like straightforward binary search. Handwritten binary search. The ID mid min of max of this plus delta ID LID RID. Okay. Yes. And now I want to find, yes, if it's too large, then just, yeah, go here. Otherwise, go here. Yeah, like this. Redeclaration indeed. Only holds 2 elements. -1 here. Is that it? Okay, let's submit. Yeah, I don't have to rebuild all these things. But like, yeah, it might just be too slow. Okay, 4 minutes. I should probably just make a big test case. Maybe it just passes and then I shouldn't worry. Yeah, okay, it just passes. It's 3.2 out of 7. Okay. All right, chat. How's it going? How did somebody solve this in 7 minutes? Yeah, I kind of want to know. Why does he use such an awful editor? What do you find awful about it? Like, yeah, like it's not an IDE, but I kind of wonder. Yeah, GG. We still have 3 minutes. Actually, I don't feel too comfortable when typing these square root problems. Like, I feel like my approach is, first of all, quite ineffective. Like, yeah, for example, in a query, I rebuilt some blocks when I definitely don't have to, but it was just faster to type this. But like, yeah, I think someone taught me how to actually type these problems easily, but yeah, I don't know. I don't like what I do. I have not met Magnus. It feels like a normal day. Well, I guess. Good day. I think the problems were pretty good, actually. You can solve problem B in n times q using pragmas. Yeah, okay. Sure. 0.6 out of 7. Yeah, it makes sense actually. Maybe I should think about it when I solve this problem. Like I have 10 to 10, right? It's just 10 to 5 square and 7 seconds. Yeah, it makes some sense that you can just do n times q. But anyway, yeah, I think the problems were actually pretty good overall. Let's take a look at the problems. Yay, Jan Java, thank you for the raid. We have just finished Snark News Winter Series 2022 round 3. We solved all problems. And yeah, the contest ends in 1 minute. Yeah, hello everyone. So yeah, problem A. What was problem A? We have some points on the plane and we want to count such points that have some given point in the same, with the same x coordinate and some one y point with the same, some different point with the same y coordinate. Yeah, so basically we just have some, yeah, okay, just refreshed because the contest ended. Okay. 5, 5, yeah, I see. Yeah, we have some grid, like we can count all the x coordinates, count all the y coordinates. And as you can see in my code, we just multiply these numbers. But then if we have a point which has no other points in this with the same x or y coordinate, then you should subtract 1 because this point does not satisfy the actual condition of the problem. It doesn't have a point in the same x and a point at the same y which is different, right? So points which have no other points at the same x and the same y should be subtracted here. Yeah. Problem B, once again, like I said, yeah, n times q passes, as someone mentioned in the chat, but we can do square root decomposition, which is basically we have some blocks. In each block, we maintain all the numbers in increasing order, and then we also maintain 3 auxiliary variables for each block. And basically it's just a transformation of each number into x plus delta, and then this number also gets chopped with L and R. So basically we transform each x into this, and when we apply operations to the whole block, each number gets transformed like this. And what is important is that the sorted order of numbers doesn't change in this case. Like this, all these 3 functions are monotonic, right? Bigger number results in bigger number always. So we don't need to sort again. And then when we have some modification query, we just take every block which is inside, like full inside the query, and we just apply the transformation to the 3 variables. And after that, we also have to take the end, like the start and the end, which is not a full block of the query, like, but we have some, maybe something at the start, which is not a full block, but some elements, and maybe something at the end as well. So we just take the block, we like kind of perform our transformation to get the actual values in this block. Then we apply the query for the part of the block, right? Only for the part of the block which belongs to the query. And then we just rebuild. We build the sorted order for both of these blocks, left and right. Yeah, and then for the query, we basically do the same. For the not full parts, we just do the same, we just count, and for the full parts, we can do binary search on our sorted order to actually find the first and the last, like the range of values which give values which belong to the segment we want to find. So yeah, that was it for problem B. Yeah. Setup tool, please. Setup does not matter that much. Just use whatever you feel comfortable with. Yeah, n times q passes in 6.5. Yeah, someone mentioned that. My solution passed in 3.2, which is, I don't know, like, I didn't even try to optimize it, right? But I probably cannot optimize it too much. But yeah, I just take block size just square root of n, for example. But maybe you can take, yeah, you can probably make it bigger, right? Or maybe smaller. Maybe actually smaller. Maybe it doesn't matter. Yeah, I don't know. There's log in both parts, right? Yeah. Yeah, okay, problem C, we are given a string, we want to split it into two parts at some point. Then we take these numbers, we add them, and we want the sum to have as many zeros at the end as possible. So what my solution eventually was, basically it was just try every possible split position, which is I. So for example, in this case, we split string into characters from 0 to I and from I plus 1 to n minus 1, right? And now we get some two numbers. We want to find how many zeros their sum has. And the idea is basically that if we know what one number ends with, we know for sure what the other number should end with for it to have zeros. Like, for example, if si plus 1 to n minus 1 ends with, let's say, I don't know, something 0, 0, then like, yeah, like this. Then we want s0i, we want this to end with like, yeah, you can figure it out, like 0, 8, 7, 2, 0, 0, right? If you want to maximize the number of zeros. So basically, 0 should be transformed to 0, 0 to 0, and then when we get the first non-zero, like this as well, after we get the first non-zero, this number should be like 10 minus that digit, and then each digit should be, okay, 7, 8, right? Yes. Then each digit should just be 9 minus the corresponding digit. And that's it, like. And what it means, I build a string of length 2n. Like here I built string b, which is transform of reverse of a plus a, like concatenation with a, with reverse a again. Okay, and transform means, for example, okay, I guess reverse of transform of a is more correct, like means, yeah, transform means just like transform something like this into something like this, like basically into the complement, like 10 to the length minus that length. And then after I build this string, what can I do? if I just use that function on the string, what does that function do? Basically, yeah, I reverse this. Yeah, it's a bit tricky to explain, more so than to actually implement. But yeah, after we use that function, we can actually, like, we know that we split string into these two values, and we just use that function to know how many characters actually match what they should match. Like, I take that value of 2n minus 1 minus I, which is actually where the i's digit goes to in the second part of the string, in the reverse part. And once again, yeah, you cannot see a bit because of my camera, but yeah, that's fine. So I take this number of characters which match, and after that, it could happen that one of the parts actually ended, but the other part could still make us some more zeros in the sum. And if some of the parts ended, for example, if the length is equal to the length of the second part, we should check if the first part, like how many more digits we can take from the first part. And if the second part is all zeros, then we should have more zeros in the first part. Otherwise, we should have more nines in the first part, which is basically this condition. And then we just take the position after the length of the second part in the first part, and we take how many more such digits equal to dig we can take. And the same happened, like similarly, when the first part ended, we take some numbers from the second part, some digits from the second part. Okay, that was a bit too much, but anyway. Yeah, I don't think this problem is boring. Yeah, I actually like, I think it's good. I don't know. I kind of enjoy this problem in particular. I know about in general, but this problem I think is pretty good. Maybe there's even an easier approach, but I think mine is pretty clear. But it has some details. Yeah, I will probably take part in tomorrow's Division 1, but I don't think I will become the first 4K in Codeforce, because, at least tomorrow, because tomorrow I don't think I can gain 89 points in one contest, even if I win it. But yeah, 2 victories should be enough, in any case. So, yeah, problem D, I don't know. Yes, I will participate in CodeJam. Yeah, problem D, I'm not sure, like, it's just kind of straightforward half-plane intersection, which I copied from CP algorithm, I think. But yeah, it's a bit, again, a bit of a shame I don't have my own implementation, and I was lazy to implement one, but it's fine. But yeah, basically, it's kind of a Voronoi diagram, but since we only have 100 points, as you can clearly see here, 100 is clearly 100. We don't need faster algorithms, but yeah, otherwise you could just build Voronoi diagram, and then it's still not like, yeah, I guess you can just build Voronoi diagram. You also have to chop it with the given rectangle and find the areas of all the parts, but it's not like, yeah, it's not hard to chop. Building the diagram is definitely hard, but in this problem you don't have to be too effective, so you just build the half planes and intersect them, and this way you build the cell for each vertex. Okay. Isn't built-in complex numbers enough for most of the operations? Yeah, I mean, you can use them. It's a bit weird because they're not like specifically created for doing geometry. Like, you can implement some geometry primitives using complex numbers, but in general I would not recommend that. I think you should just have a dedicated class. But I mean, I'm not 100% sure. Like, if you're in an ICPC contest where you cannot copy anything, then maybe it's the fastest way to actually implement some geometry. I haven't actually done that, and I don't know anyone who did that or does that, but it could be the case. I don't know. Okay, problem E. It was a bit weird. We have to find two cliques of size x and y, at least x and at least y, so that every vertex belongs to, like in an undirected graph, so that each vertex belongs to at least one clique, and yeah, we have to count ways. And here we just note that when we have two cliques and each vertex belongs to at least one of the cliques, then if we take the complement of the given graph, then like we have independent sets instead, and basically the complement should be bipartite, and we just take each connected component in our graph, we color it into two colors. Like if a component is not colorable, then we have just 0 ways because it has to be bipartite. And after we know it is bipartite, we find how many vertices we have in each part, in each component, but we can color them like in one way or the other way, right? We have 2 ways in each component. And also we do some dynamic programming like knapsack, but with 2 variables, like how many vertices we have belonging to one component right now and the other component right now. And we just go from, like, yeah, for each component, we update our dynamic programming, which is just we go through the old sizes, we make forward transitions. Okay, sum is the sum of colors, which is the number of ones we have, and count minus sum is the number of zeros we have. But we can do them one way or the other way. And also, if we have just one vertex in a component, then we can assign it to both cliques, actually. So we have one more transition in this case. And yeah, in the end, we just sum the dp values over all k0 and k1 from x and from y respectively. So that's it. That's n cube for 502 seconds. But yeah, it passed in just 0.2, so it's pretty good. Yep. Neil holds the first place in lead code for 3 years already. Well, I'm pretty happy for Neil, but I don't feel like doing lead code specifically for me is what I would enjoy right now, and I try to do mostly what I would enjoy. In ICPC originals you did that, dot product and outer product you have to make functions for, but at least you don't have to type all the plus minus divide and multiply operations. Yeah, sure. Yeah, I think it's okay. It's also a bit annoying, like when you need integer geometry, you can use complex of int, right? But that's sketchy, to say the least. Right? Complex of int is kind of not really defined well, I think. Yeah. It is undefined behavior, but it works. Reportedly works, right? Nobody said it doesn't. Nobody actually found, nobody actually encountered undefined behaviors, right? Using it. No, I don't use Rust, but maybe I would like to try it at some point. Okay, and finally problem F. Yeah, I do use Python sometimes. In problem F, we had some graph with n vertices and m edges, and we could make at most k changes. A change is either removing an edge or adding an edge. And we also have some values ci, which are the maximum degree of a vertex that we can have. And we know that the given graph satisfies this condition. we want, after all the changes we do, we want all the conditions to still be satisfied. We want each vertex to have degree at most ci, and then we want to make at most k changes to transform the graph into one connected component. Just one, right? So we want to make it fully connected. Do I use Python for test generating and check? Actually, no. For some reason, I usually do that in C++ still. I think it's not much faster to type like test generator in Python. I usually do it in C++ still. I sometimes use Python like maybe for loan arithmetics or maybe for something like, I don't know, maybe for fun. Not in this case though. Yeah, so problem F, what was the solution? Yeah, it's a bit tricky test cases, like cases, not test cases, but a bit tricky cases. But first of all, the total degree should be at least 2 times n minus 1. If it's not the case, then it's always null. Otherwise, we can always make the graph connected. We can just remove all the edges and make some tree. And it's well known that all degrees, if the total of degrees is 2 times n minus 1, then we can make a tree in any case. Well, all degrees should be at least 1, but it's given that all degrees are at least 1. So we can always make the graph one connected component, but we should make it in at most k steps. And the question is, can we do that in k steps? So what we do is we find all connected components as we have them. And there are some cases. For example, if we have just one connected component already, like we have a component of size n, where n is the number of vertices we have, then it's always just yes. We don't need to make any changes. Then we have a component, we have some number of edges that we can count, like how many edges we have inside the component. And we have some free like slots, I call them, like free connections, right? So like how many more edges we can connect to this component. And there are cases, again, like if we have at least one slot in a component, then we don't need to actually do anything inside the component, probably, but we'll see later. And I maintain 3 variables, comps, res, and slots. Comps is the number of components I have. Res is the number of like overall changes I need to make. And in this for loop, I only count removals of edges. And after that, I count for adding edges as well. And slots is the number of slots overall I have in my connected components, like free slots. And again, like if returning to this for loop, if I have at least one connection, free connection in a component, then I just increase number of components by 1, the number of connections by that number. Otherwise, if I don't have any free connections inside the component, I have to do something with this component because I just cannot connect it to the rest of the graph otherwise. So I have to remove at least one edge. And there are 2 cases actually. If the component is a tree, then removing any edge results in 2 components, right? And I can just check that if the number of edges is equal to size of the component minus 1, then it's a tree. So when I remove an edge, I have 2 more components, and I need to make 1 removal, right? So I increase the res by 1. And otherwise, if it's not a tree, I remove 1 edge, and the number of components increases just by 1. And res also increases by 1, and also slots increase by 2 because I have 0. After I remove 1 edge, I have 2 more slots. And in the end, since I have comps components, I just increase the answer by comps minus 1, which is the number of connections, additional connections I should create to connect them all into one component. But there's also a different corner, like maybe a corner case, I don't know, whatever you call it, that sometimes you still don't have enough free slots in your connected components, right? For example, if you have 3 components and each has just 1 slot, you cannot connect them. So you need to remove more edges inside some of the components. And actually don't care which edges and inside which components you remove, as long as you don't disconnect anything. And so you just removing any edge increases the number of slots by 2. And we need diff, which is like difference of these two variables, right? These two values. We need this diff more slots, and every removal, as I said, increases the number of slots by 2. So we just divide diff by 2, round up. So we just add 1 before dividing, and this way we get how many more removals we have to make. But we know that we will always be able to succeed because we already checked that the total is at least 2 times n minus 1, so we don't need to care which edges inside the components we actually remove. We just take any of them. And like we know that we will be able to find such edges. And yeah, that's it. We just compare the number of steps we made, the number of changes we made with k, and print yes or no. Yeah. I feel uncomfortable seeing a variable highlighted in white. Yeah, I kind of agree. I was surprised that slots got white. It should not. 3 slots. Okay. Let's not make people uncomfortable. Should be fine. Yeah. Okay. That was problem F, and okay. Yeah, actually, yeah, a bunch of people solved 5. Our American friends solved 4 and 4. I think this contest was kind of interesting. Like, also, it wasn't. Yeah, probably after A, E is the next problem to solve. But then out of like C, D, well, maybe I'm not sure if F is actually the hardest problem. But yeah, probably it is. It requires the most care. I don't know. C also requires some care, but I don't know, like 18 people solved C. Is there an easier solution to C than the one I had with that function? I don't actually know. Yeah, you spent too long on C. Yeah, I don't know. Is there an easier approach? Maybe. Because actually a lot of people solved it. But yeah, I think out of the 3 rounds, this one is definitely the most interesting one. Couldn't solve anything but A. Yeah, that's a shame. Could you maybe not understand the problems? Yeah, I guess it's still a bit annoying to read them in English. But yeah. I don't know, D is kind of know where to copy from and maybe also read it. Like many people will just skip geometry, right? Because it's geometry, but actually this problem is kind of easy if you have the geometry primitives. You didn't have this neat transformation for building B. You had 9 minus AI for all digits and drown in cases. Okay, yeah, I guess that, like, yeah, you actually didn't solve C, but yeah, maybe people just handle the cases better. That function idea is not too hard. Okay, yeah. I thought it's okay to do maybe binary search on hashes instead of Z function, but then I just figured out you can just use that function here. Yeah, I think I will end pretty soon. Just wrap up the stream. So today was a good day in terms of our result, which is satisfying. Did I absolve? No, I did not. I didn't solve two. I actually didn't solve 2 problems last contest, A and B. Yeah, I did not do either of them. want to rate someone. Do you have any good candidates to rate? Because, yeah, I wish we could have more, I don't know, streams to rate. And we don't have that many of them. Call Eknerwala. I think it's Friday. Right? Yeah, it's Friday. So I think he's probably working. I mean, it's Friday in the US still. Do I plan to stream contests other than SNWS? Yeah, I think sometimes. I did stream Code Forces round 2, around Division 2 last week. But yeah, we haven't had other Code Forces contests. You did both, and for B, your solution passed in 0.3 seconds, but the case you suggested took 12 seconds. Yeah, so yeah, just implement DDP and then just hope that the cases are not maximal, yeah. And A, how bad was A? Was it too tricky to implement? I thought that there should be many cases, but maybe it's not that bad. But yeah, some cases, yeah, okay. Makes sense. Okay, sure. So I'm not seeing anyone to actually right now, but just be sure to stream yourself then, and also post your stream on Code Forces, and then once you do that, you will very likely be rated by someone, maybe by me, probably by me. So just, yeah, just do your own streams, right? The pattern contains at most 2 extremas, so you need to handle 0, 1, 2 separately. Yeah, I see. It's okay. Yeah, it's okay. Should you give up Java? I don't think so. I don't think you should. In general, most problems, in most problems you will not encounter any difficulties with Java. And then some problem setters don't really try to satisfy Java users, and some problem setters do set strict time limits, which happens maybe somewhat often. And yeah, I actually feel for Java users. I don't think that should actually happen, and strict time limits should not be the case in many cases when they are. I think that I would encourage problem setters to actually think about Java and not set unreasonable time limits. And for Java users, yeah, I would just support you in your using of the language, for the lack of better words. Those n square root log, it's a bit difficult to separate from n square. Yeah, I'm not sure, did anyone want to try to separate it? Maybe not. Okay, guys. Yeah, thanks a lot for watching, everyone. Thanks all for hanging in here. As always, the next stream will happen no later than in 5 days on the 26th of January. We will have Snark News Series round 4, which will happen then. And maybe before that, I will occasionally stream some Code Forces or AdCoder or something else. We'll see. And I will just announce them. I guess just on Code Forces. Like, yeah, I will just put my stream here. But as always, don't forget to follow me on Twitch to get instant notifications about my future streams and not miss them. Yeah. Thanks all and goodbye. Take care.